There we go. Okay. Hello. Oh, excuse me. Hello, SolarLune here. Welcome to another game dev stream. Or another stream. This is a game dev stream. So, hello. How's everybody doing? If you're in the future, what's it like living in the future? And if you're living in the present, what's it like living in the past? Because even the present's in the past because of how long it takes neural impulses to reach our brains. So anyway, yes, hello everybody. Hello everyone in chat. How are you feeling today? I did some work on the Tetra3D yesterday and added lighting, vertex-based lighting, which is cool. So this is more so kind of in line with like a PlayStation 1-ish capabilities, where you can, have like dynamic lighting and stuff. There's only, well, not only, but there's 3 light types, which is point lights, um, ambient lights, and directional / sun lights, which is cool. So in this scene, there's 5 lights, 3-point lights, 1 ambient light, and 1 sunlight. As you can see, the tops of the boxes are bluer, and then the sides are darker. The back side is darker. So that's cool. Yeah, so this is not doing too shabbily. I wish it was faster, but wishes mean nothing in the world of of programming. You have to actually make it happen. So yes, overall this is pretty good. I'll see if I can optimize things even more so, and I'll keep optimizing as I work on it, work on this renderer. So that's cool. So I'm jazzed about this. This is pretty sick, pretty sick. Yeah. So now, what we'll do is actually use this to kind of work on something, and then as we work on it, we will also see what needs to be improved in terms of the API, what needs to be fixed, if there's any fixes, issues, or anything like that. Hello everybody in chat once again. Chipwreck says catching this stream at lunch, which is pretty cool. That's cool. Yeah, it's cool to have people popping in at lunch, or when you have a moment. And so this is the game I was kind of starting working on, where you control this little dude. The idea is basically you play this suit guy who has to go into a shut-in's house and help the person basically like come outside. That's the general idea. So he's kind of this like weirdly menacing character, this guy, but basically he's the protagonist as he goes ahead and tries to get the I don't even know what you'd call it. I guess the deuteragonist, the person in the house to come out, and he's like he doesn't want to come out because of oh, is it, did it freeze? I think my screen capture froze. Hold on. Hold up. I think it froze. Hold on. Yo, it was frozen that entire time. All right, well, at least somebody said it. At least somebody told me. At least somebody told me. Let me go back. Let me go back and re-show what I was talking about. Yeah, apologies. my screen capture froze, I think, because I changed the screen size after I started OBS. Okay, so here we go. Back to it. All right, so yesterday I added vertex lighting, and so this is what we have here. So in this scene, this is the scene I was talking about. There's 5 lights. There's 3-point lights. One of them is moving in the center. Then there's a red light over there, a green light over here, and a sunlight, which is invisible but is casting blue light on top. And there's also an ambient light. So overall, it's taken like 2 to 5 milliseconds to light all of this, this scene, which is a lot of time, but at the same time, there's a lot of triangles here, because each of these squares is 2 triangles. So that's kind of a lot. In practice, if you were making like a PlayStation 1 kind of game, you wouldn't have this many triangles. You wouldn't be rendering this many triangles. So it's not too big of a deal. Your draw distance wouldn't be this far. Your ground wouldn't be this tessellated. So it's probably okay for now. But I'll see about optimizing it in the future. But yeah, this is pretty cool. Not bad at all. Right. So what I was talking about actually doing with this is basically we could start working with working with Tetra3D to make something cool. And by working with it, we'll see if there's any fixes that need to be done, as well as improve any API issues or things like that. Let me also get some music going. EK says the fact that this is all running in Ebiton is especially cool. Yeah, I like it. I like that. As crazy as it is that this is like a software renderer, you really should be using a 3D renderer, a 3D engine if you're going to be doing 3D. The idea that you can do everything that this is all running in Ebiton is cool, because it's like, okay, if I can optimize it hard enough, which I might be able to do, you might be able to run this anywhere you could run Ebiton. So on the web you can run this, on Android or iOS you can run this, and certain devices like web may not be fast enough to render a relatively complicated scene, but at the same time it might be enough to, well, it's good to have the option. And then depending on the use case of your game, you might not need a full 3D scene. You might need just like a spinning coin or a logo or something, which would make this which is really a good option to have this capability for 2D games. But this is what I was talking about. So this is what I have, and let me get the music up and going. I guess I'll go with oh, that's loud. Ow. Hold on. Where's... Okay. Yeah, it's let's make it a little quieter. Somewhere around there probably is fine. But yeah. So basically, this is a game where you play a suited character. He is coming into a house. Basically a shut-in's house, which is going to be full of boxes and garbage and stuff, and he has to essentially solve puzzles and help the shut-in to leave. That's the general idea. He's a vaguely menacing character. He looks a little weird, a little dark. Not dark, but just a little like, he looks kind of alien-like. I like that aesthetic of just like kind of a weird character, but yeah, overall it's not too bad, not too shabby. There's no collision yet. So that's what we'll be doing today. We should be able to do that. It shouldn't be too difficult. EK says maybe something in the vein of Grim Fandango would be a good fit for this, where the backgrounds are pre-rendered and the characters are 3D. It's a cool aesthetic too. That's true. The pre-rendered background and 3D characters approach is good. It does work pretty well. Not sure if I'm going to go with that for this, just because to pre-render backgrounds means I have to make an entire I have to make an entire system that would... It's possible, but I feel like that's more work than I'm willing to put in for this, because you have to make cool backgrounds. You can't just make a rudimentary 3D game. It has to be like a visually impressive. You have to put more detail into the backgrounds. You can't say oh well, it looks bad because it's it's a software renderer and it's running in, that's the aesthetic. If you go for a pre-rendered backgrounds, it's like, well, now the backgrounds have to be solid. So I don't know if I want to put that much time and effort into it. Although I do appreciate that the aesthetic could be really on another level, to be honest. Okay. So what we're gonna do is, yeah, we're gonna implement physics, basically, a little bit. So in order to do this, let's close all the others. Let's push this down. It's over. Yeah. What we're gonna do. So this is our scene as we have it here. I'm unsure if we will need to / want to rotate the camera. Let me take a little bit of another look at this. Yeah, we could definitely rotate the camera here. I don't know. I don't know if we'll want to rotate the camera. Also, I think there might be too much wall. I think I want more well, let me think. Also, he just straight up disappears. Let's see if we can fix that real quick. All right, let's see. Let's see what's going on with this movement. Yeah, it's always something. Oh, I see. We want to. Oh, I see. Okay, we went. There we go. Yeah. So the way that physics is going to work here, that did not solve it. Yeah, okay, so here's what we're gonna do. We're gonna say if it's greater than friction, I guess that's probably fine. So it's just, it's always like greater enough. I think it's basically 0, but it's like a floating point error. Yeah, there we go. Okay. That's interesting. Why does write not? Oh, okay, we'll just do it like this. There we go. Black Indie Dev says hello or waves. Hi. All right, cool. All right, very cool, very cool. So yeah, physics. So the way that physics is going to work here, and yeah, I'm just gonna straight up remove this entire upper half of the room. We're gonna go ahead and purple alpaca coding gives that's sun behind the clouds? Is that a sun behind the clouds emoji? Is there such a thing? I don't know what emoji that is. I've never seen that before. I can't even I can't even find it. Is it sun? Is it a sun emoji? All right. Well, anyway, let's see. So yeah, what we're gonna do, the way that we're gonna get this to work, I have no idea. Let's what we're gonna do, we're gonna set this up using a custom property, where we basically say this is it's going to be a collision. And we're gonna say it's triangles. There we go. So what this means is if we have a property, well, the way that Tetra3D works, it will export, or the way GLTF works for the default explorer in Blender, it will export any custom properties and put them on, export them with the file. So I think materials, objects, maybe meshes, all have custom properties that can be exported using GLTF, so and imported into Tetra. So by doing this, we should be able to read this and say, oh, this requires basically a triangle thing, and we'll do the same thing for. Actually, let's save this. We'll do the same thing for. Actually, let's export this before I forget. We'll do the same thing for humans, the humans file, which is where our character lives. We will, on his armature, we will make a collision property. It will be string, and it will be capsule. We'll export that as well. Okay. So now we'll go back over here, and then when we go to actually make this, we'll see if we can get it to work. So when we initialize the level, head in the clouds, I'm not sure. I've never seen that emoji before either. Yeah, I don't know what this emoji is. I've never seen it before. I just straight up, I don't know. I don't know. Let's see. Okay, so what we're gonna do, we're gonna loop through. Okay, we have the empty for the player. Okay, I guess we could set it up here, but yeah, I guess we could set it up here. Yeah, all right. So we're gonna do this again, because this is basically where we'll like sub in any empties or anything for actual objects. So then we'll say basically for scene graph. Also, I guess we can say player scene.remove root.children recursive false. If in dot how did hold up, did I ever export this? Did I never export the properties? Oh no, tags, that's how I do it. Okay. Okay. Let's see, can't use empty as game object. Oh, scene dot scene graph root. There we go. Okay. Is this how I did it? I don't quite remember. Let me pull up Tetra3D. I don't quite recall how this works, or how I implement. Yeah, okay. So mesh materials. And nodes themselves. Okay, so then yeah, that should definitely work. Okay, let's try this. Not sure if this will work, but let's see. Okay, so it's empty. It's 4 objects. The player, the camera, map, and the camera helper. Okay. Why is it empty? This definitely should export. Let's see. Oh, yeah, you have to turn it on. I completely forgot you have to turn on that that feature. There we go. Okay. All right, now we have one, but the other one is not there. Let's see. Which one is not there? The player? Oh, the player's not even here. Let's see. Okay, let's. Oh, it's because it's not there yet. I see. It gets added later. Okay. All right, we're good. We're good. So then what we will do. Let me think. Glyco says, I love the music, by the way. Thank you. Thank you very much. This is really just like the backing of this game. This doesn't really have anything to do with Tetris specifically. Tetris API, rather. Because we're adding the object, and we're doing it later in the loop, once the scene draws first. Really, we want to kind of do this before. I guess we'll just do it like this. Just to make it a little easier for us. Alright, so we have the armature there now. We have the plane. But the character isn't there. Or not the character isn't there. His tag isn't being loaded. Am I cloning it properly? No. Yeah, that's the problem. Okay, so I'm glad I did this then. I'm glad I am doing this test. Or, you know, making this game. Because that allows us to see where we were forgetting to do stuff. So, in node, when we go ahead and clone a node, we need to clone the tags as well. So, we'll do that here. There we go. And that might be it, actually. Let's go ahead and see if that solves it. Here we go. So there's the armature, and it now has collision capsule, and then here's the plane with collision triangles. All right, cool. Let's commit this before we forget. Okay. There we go. Oh, this. Okay. All right. So now that we have this information, we can basically just say for every object, if it has a collision tag, then we can just make a collision object for it. We say if in.tags.get collision. Well, I guess we'll just say. Do it like this, actually. I'll leave that alone for now. Switch whole dot. Well, switch case triangles. Whoops. Add child. New triangle. Triangles. And we will use the mesh of. We'll assume that the object is a model because it shouldn't be any other way to do this. We'll go like that. And then other case will be capsule. The height should be. Now the thing is, when we go back to here, there's no actual capsule like there's no way to know how tall this object is, in a sense. So it might be better to put it on the mesh because that does have a definite dimension size, whereas this is just like individual nodes. So we could either assume the capsule is a certain size, or we can put it on the mesh. That might be the better approach. Let's do it this way. We will put it on the mesh. We'll put it on the mesh here. So that way it has a definitive size. I'm wondering if I should just do this programmatically. Oh, what am I thinking? Of course, that would be an easier way to do it. Let's just do it like this. Let's just do it programmatically. No, let's do it logically. We will make a cube. This represents a capsule. We will make it visibility. We will make it viewport display. We will make it wireframe, like so. Save. This will be our bounds. We will parent it to the armature. We will say string collision, and this will be capsule. All right, let's try that. Yeah, let's try something like this. Center, origin to center of mass. All right, so this should give us kind of what we're looking for. I probably should have done this maybe in a different order. Let's parent the armature to the object, the bounds. There we go. This should also be. Okay, so you move the bounds. We'll just call this the pseudonym. This will be shadow. This is the armature. And then this is the mesh. There we go. Okay, this is a better setup, I think. Yeah, okay, let's try that. We'll export this as a GLTF. Now, there's no way to like turn this into a capsule, unfortunately. So we'll have to do it manually, I suppose. That makes no sense. I'm trying to figure out how I should do this, dude. It's such a like how do I want it to work? All right, here's how we're gonna do it. Here's how we're gonna do it. That doesn't make sense. Nightmare Zero says hello. Hello, welcome to the stream. I'm waffling. I'm trying to figure out how do I want to set this up. I like this hierarchy, but the issue is when we put this in the game, this will be a cube. Naturally, it will be an object. We don't really want it to be an object. We want it to be something that gets converted essentially to a capsule object or any other collision type. It would be cool if we could kind of like do this. Maybe we should make it so that the GLTF importer basically reads this. Nah, this is too cumbersome. This is really something for me as the developer of a game, as opposed to the API. This shouldn't be in the API. Okay, this is not very elegant. If I was trying to solve this like permanently, I would make an add-on for Tetra that basically gives you like the collision options, like the Blender game engine used to do it. But that's okay. We'll just do it like this. We'll say this is a capsule. when we go okay. Okay, that's what we'll do. Okay, I think I got it. So this is basically we're parsing. So yeah, that's what. Okay. Okay, I think I'm getting it. Hold on. Hold on. For now, let's not get caught up, get tangled in the weeds. Let's make this as simple as possible. Let's just do this programmatically. Sense. I'm thinking, dude. My mind is like, I'm trying to figure out how do I want to approach this, because fundamentally, when we go to run the game, like so. Well, I guess it would crash. I guess that makes sense. That's right, because we changed the hierarchy. Like when we run the game, how do we want to set the collision to work? I think this is better. We'll go with this. Yes. So then the root should be this guy, good man. So then it's now armature. Oh no, it's just suited man. Okay. Model. Okay, so it is broken. Not broken, but like it's not, we don't see our guy. So let's see what's going on. Yeah, okay. Root. Getting this. Means everything. Alright, we're cloning it. Alright. Okay. Are we? Yeah, we are. Okay, we're adding it to the scene. Oh, that was my bad. Okay. Yeah, perfect. Now, the camera, we have to update it. Yeah, it needs to be. There we go. Some pseudo-ban. All right, cool. We want that to be invisible, so now we will. Oh, I hadn't considered. There's no way to make a single node invisible. Oh, I hadn't thought about that. Oh. All right, let's add that option. I hadn't even considered that. I think visibility might be. Okay, so you can set visible on an individual node. And then we could also have it be recursive. Now, the idea behind setting visibility recursively, I'm not going to probably propagate it down properly, because that feels like it might be prone to, well, I guess that kind of makes sense, right? Like you have a child, or you have a node, it's visible, it has two children, you say set this to be invisible, propagate it, it sets those to be invisible. You can then set them to be visible individually. Yes, okay, that makes sense. So does that make sense? Well, it's already recursive, so we know that's true. Okay. Now let's go back. Set visible. Recursive. Cool. Okay, so that actually does give us something that we didn't have before. That's cool. Okay. So in this example, if we want just the cube to be invisible, we can do that. Now when we go back, actually, if we go to main camera, when we traverse the nodes, oh, we want just, it does work this way. So it only gives us the visible children recursive. Only if not only visible or child.visible. Bonk. Let's simplify this. So, oops. So this always will work with every child, not just the visible ones. That makes more sense. And when we do this, we can just loop through. This always, yeah, this already didn't make much sense. Also, hello, Music Boy J Boy, welcome to the stream. Thank you very much for stopping by. But yeah, this already didn't make sense because I was basically looping through getting the children, the recursive children of the root node, only the visible children, and then on top of that, only getting the ones that are visible, basically, that are models. So yeah, we don't have to do that. We can say if okay and model dot. I don't think we already do that. We don't have to do this. Well, I guess it doesn't hurt to do it earlier rather than later. No, we're already doing it twice. There's no need to do it twice. Cool. All right, now set visible. Okay, so now all that work. Let's make sure it. Oh wait, hold on. Still got some crashes, some issues here. Cool. Now let's make sure it still works the same. It should. Brat. Wait, hold on. We have to fix some stuff in here eventually, so I'm just gonna do that real quick right now. These examples. Okay, so oh no, it's here. Okay. we will reload this window. Isn't there a reopen? There we go. So let's make sure it works the same. Should work the same. Seems to work the same. Cool. Now the whole reason why we did this was that when we go to make the player, we can just go player.root.setVisible false false. So just that cube is invisible now. Yo, let's go. Excellent. Now let's make this as simple as possible. We're just going to say player.root.add children capsule equals new capsule. Capsule. This will be of player.root dimensions. We want the vertical dimension. Vertical height, and then the width. I think I have this. We can just say height, yeah. And then width. It doesn't really matter if it's width or depth. And then we just add it as the capsule. We're gonna go to main, or rather the scene update. And we'll put it in draw. Can we get scene.root tree to string? Okay. So now we should be able to see what our tree looks like down here at the bottom. All right. So we got the plane. Yeah. I think that's this map, this hallway. Yeah, plane. We got the hallway, which has bounding triangles now. We have the helper, which has his camera, which also has his orientation fix. It's got we got our suited man. It's got his armature with its mesh. Got our shadow, and we have our bounding capsule, which is cool. All right, and the letters indicate the kind of node it is. So plus is a node, M is a model, tri is of course triangles, C is for camera. Yeah, cap is for capsule. So the capsule should be basically around our character. Should be. So if this was working, we should be able to visualize this. Well, let's visualize it first, so we can kind of make sure it is working correctly. Debug, bounce, screen. We want scene graph root, and we want you mean like a something like that. All right. Okay. Cool. So this is working. As you can see, the capsule is way too wide. It's entirely too wide. That's because we use the width of the character as the radius. It should be width divided by 2 for the radius. All right, better. It feels like it's too tall. Yeah, it's definitely too tall. Height again, divided by 2. But no, wait, hold on, because the height. Well, hold on. There's a couple things here. So this is the radius. We also want it to be the height minus the radius. But the height should be like, this is... We're already chopping the height in half. The height might be incorrect. Let me see. the height is 1.8. Is that correct? I think it is. Yeah, 1.9, 1.8. Yeah. It was, I think it might have just rounded down or not been. Yeah, 1.89. So 1.9 is the height. But why is the bounding capsule so big? Psycho says, it's impressive how you managed to keep Tetra3D clean while hacking on your new project. Thank you. Yeah, it's... Or it might just be... It's not transformed. Okay, it's just not... It's not... It's the right height. It's just too low. Thanks. Whenever I have a similar flow, I end up fixing destroying my side engine to make it fit my game as well. Yeah, it's interesting. Definitely is kind of an interesting process to like try to kind of not like reach into your engine. You want to keep it generic if possible, kind of like a generic engine if possible. So yeah, the position is just too low. Why? Oh, we just didn't move it. My bad. I completely forgot. We just have to set the world position, or set the local position to be player root mesh dimensions center. My bad, I forgot. So now it should be like up where it should be, a little better. It is not. Where's the center? Yeah, this is the center, right? Let's see. Is it negative? Let's see. Center is 0, 0, 0. That is that's patently incorrect. The center is definitely... I guess it is 0, 0, 0. Where am I putting the player? Root.set world position empty.world position. Yeah, okay, so then yeah, it definitely should be in the right position. And he's not going through the floor, so he's where he should be. But why is the capsule low? Alright, this will require us to draw the debug centers so we can see where things are. Okay, yeah, so the capsule is there. It definitely should be higher. Why is it low? Okay. Yeah, I know why it's low. See, I think the issue is that when I parent stuff, I try to keep it in the position that it currently is in. That's not necessary, I guess. This is kind of bitten me a couple of times. Also, hello, Big Reggie. Welcome to the stream. It's been a while. Welcome. But yeah, I think I try to like preserve the location because that's what Blender does. But maybe I shouldn't do that. Like if you have a cube like this, right? And you say like, oh, let me move this cube over here, and then you parent this, like it keeps the same like location. It keeps the same relative location. When in games, maybe you don't want to do that. Maybe that's not really what you want to do. Anyway, we'll solve this by saying set the world position of the capsule to be the same as the player. Oh, well, I guess that makes sense. Yeah, so we'll just set it to be just something like this instead. There we go. So just make the capsule and the player position like be the same. There we go. It's a little tall, but that's closer. It's definitely closer. Let's see. I think it's rad times 2 actually. There we go. better. Yeah, that's better. Okay, now we just have to actually make it so that you can not walk through walls and stuff. That's the next step. TJK says, what's the stress test limits of a software renderer? I imagine it's pretty low, assuming the GPU can be used for processing. Yeah, it's not nearly like as good as it could be or should be, or it's not. Hold on. It's not at the level of Unreal. We'll say that to be sure. Oh, I might be bad. Hold on. There we go. It's okay. Like I don't know if this will come out on stream, but this is the best stress test I've gotten so far, which is not bad actually. 40 FPS, drawing transforming 32,000 triangles and drawing 16,000 of them at 40 FPS. So this is definitely okay. It's not like. It's not great. It's not great, to be sure. Like I would like, of course, in the hundreds of thousands of triangles if possible. And maybe I can get there with some optimization, but it's never going to be even close to a GPU. But the upside of this is that, yeah, like you mentioned, TJK, it's really compatible. It's very easy to use in terms of like, being able to use Ableton to make a 2D game and then just kind of like smush this in. That's great because it's like you don't have to say like, oh, I started making this game in GameMaker, and I guess that's kind of a similar concept because I know some people do this with GameMaker too, like do a software rendering or something like that. But if you're making a game in GameMaker and it's a 2D game and then it's like I just want to draw this one 3D object, it's good to not have to like switch engines or anything like that. You can just use a software renderer for something simple like that. And I think GameMaker does have DirectX, as I recalled, way back in the day. And right now, I don't know if it switched to Vulkan or OpenGL or what, or if they have different backends, because I know GameMaker works on different platforms. But I remember it having like a very basic Direct3D API back in like GameMaker 8, something like that, 7, 8. Don't Mind Me says, what CPU are you using? I'm using a relatively, it was powerful when it was okay when I got it. That was maybe like 8 months ago. Let me see if I can pull it up. It was like, it wasn't bad. Like 8 months ago, a Ryzen 5 1600, 6 core. So it's like 3 point something core, 3 point something gigahertz. Like this is a powerful, a pretty good CPU, but it's not like fantastic. 3.6 gigahertz. It's a few years old now. 3.2. Let me pull this over. 3.2 gigahertz base. I think it can overclock to maybe 4 gigahertz, and it's got 6 cores. But this is a single core renderer. I haven't multi-threaded it. I tried it, but it wasn't really taking, so I just decided to back off. 3.6 gigahertz max, so it's pretty fast. But considering that this is single core, you're not really like, I'm not pushing it as hard as I could, and on top of that, it's not excuse me. On top of that, it's not optimized. Like I still need to optimize it. I still need to multi-thread it. It's still using only one core, and it's doing 40,000 triangles. So like on a normal computer, you could probably expect maybe 10,000 or 30,000 triangles. On a normal computer, you could probably expect like 5,000 triangles, which is fine. I think that's fine for 60 FPS. Like 5,000, 4,000 for a basic like PlayStation 1-ish game. And then again, I still have to multi-thread it. I still have to optimize it. So hopefully I can get it into the range of like 100,000 triangles with some effort on this computer. But even so, like my computer is not like groundbreaking. It's strong, but it's not that like modern. It's not a super like gamer computer. Like it's good, but it's not like some people's that's just like kitted out to the maximum. It's just kind of like it's a pretty stable game computer, like a mid-range. Elmar says, isn't Ableton using the GPU as well? Yes, Ableton does use the GPU, and I do use the GPU as with Ableton to draw the triangles, of course, but then also I do use a shader to do depth testing, because that's the only way I could really think of to do it. To do depth testing between objects is basically when you draw an object, you draw all the triangles for that object. Then when you draw another object, you can compare the depth texture that you. Let me see if I can. I guess we'll just go to lighting demo. That's fine. Basically, you can examine the depth textures to see where things are. So, like in this example, I turned on the depth texture visualization. When you, I can't really point to the screen, unfortunately, because the mouse cursor is hidden. But when you draw, for example, the cube that's furthest back, which is that one there, it draws first, right? And then you draw this one in front, and it draws second. Now, if you were to draw them in reverse order, where this one is drawn first, when you draw that second cube, you can look at the depth texture that was generated from the previous cube and see, oh, this cube is in front, so I can discard the bottom parts of the cube. You can kind of visualize this if you, or see the effect if you go in here and turn off depth, render depth. If you turn off render depth, then it will now have to sort the objects by distance, which is not bad, but it's not good either. Also, yeah, you can see the problem that comes in, because the distance to the ground is closer than the distance to these cubes, and so when we get closer, now it starts drawing them on top. So this is definitely faster than using a depth texture, which is, you can see now, blank. But the problem is, obviously, there's no inter-object depth testing. So you have to be close to the objects to draw them in sequence. And if you're closer to any object than another one, then you get some render artifacts like this. So the way to really solve this, if you didn't want to use a depth texture, is to try to break up as much of the geometry into individual objects and then just draw them that way. Or alternatively, merge everything together and then draw them according to distance to the camera, which is what I do for the triangles in an object, in an individual object, which works okay. But the downside of it is there's no inter-object depth testing. So if you have a complicated mesh, all you can do is draw the triangles from back to front. You can't have them intersect, which is fine for a PlayStation 1 style renderer, but for something more complicated, you'll want something better. Anyway, it's a cool little effect. Cool little effect. Yeah, but with the depth texture, it just looks like a normal 3D scene, more or less. There's some like artifacts, not on the UV mapping like this. This is just like a PlayStation 1, you know. The texture mapping is affine, it's not perspective corrected. So that means that the closer and the like more wild the angles get, the crazier the texture mapping is. And that's, you know, kind of something that the PlayStation 1 did as well, so I'm not really in a hurry to fix it or to provide an alternative. That's fine. But as you can see, the cube has this like pattern on the bottom of it. The cubes have a pattern on the bottom because they're intersecting with the ground. But that's what the depth texture is basically informing the cube as to, you know, where the border is, where the edges are. The closer the far is to the camera, the more accurate the depth texture is, and the better that effect will look. It won't look so bad. But the further out the camera far distance is, the less precision you have on the depth texture, and so that's the result you get. I need to probably make it so that the depth texture is logarithmic rather than linear, because that would allow me to get more precision in the front. Basically, you know, close to the camera, and then lose it in the far distance, which is not that big of a deal. I think that would be a good approach. Anyway, DJK says, I heard you can use the GPU with SDL. Maybe it's possible to create a software-like renderer using the SDL API. I believe so, yes. You can draw triangles, so that should be possible. The only thing is you probably wouldn't want to do that with Go, because as far as I know, the Go C, like, what's the word? But, you know, the the batching. Like the triangles need to be batched. You need to send as much data to the C side as possible from Go, so that you cross it as little as possible. And I'm mentioning this because basically I believe when you go to like the Go SDL, when you go to use Go SDL to draw a triangle, I'm going to assume it's just going to draw a triangle. I don't know if you can send a batch of triangles through Go to SDL, which then sends it to the GPU. Maybe it will. I believe that's what Ebitin's doing, and that's why I'm able to do it so fast. I think if I was not doing it, if Ebitin was not doing it, I think it would be prohibitive because it would be so slow to draw individual triangles. But now that I think about it, that's probably stupid to think of anyway. I don't think even in C, SDL probably draws individual triangles. It probably does use some sort of batching system to draw them, together, because sending individual triangles and then flushing the graphics card is so slow, I believe. So I take that back. You probably could do it with Go SDL as well. Elmar Van says, how is it software only? It's not really software only. It's more of a hybrid. It's mostly software because I'm doing a lot of stuff in software. I'm doing the matrix multiplication. I'm transforming the vertices. I'm animating. Everything is, in Go except for sending it to the GPU, which uses Ebitin, which uses the GPU, and using a depth texture or depth testing, which uses the GPU to like run a shader. Like it's an actual shader. Where's the camera at? It's a shader here that basically says like, oh hey, is like okay, and yeah, is there like something there? If nothing's there, or if what's there is further than your own depth, then go ahead and draw the object. Essentially, that's the depth texture. That's how depth texture intersection, or inner object intersection via depth texture polling, I guess you could say, how that works. And then the color shader basically does the same thing, using the depth texture to determine if the object should draw the color. So it's a little wonky, to say the least. It's wonky. I'm not gonna say it's not wonky, but it works surprisingly well. It looks like it's 3D. The rasterization is done on Ebitin So GPU. Yeah, I'm not gonna. It's not like a pure hardware renderer or a pure software renderer. But I mean, this is as close as I think you can get in Go, while still like having 3D and not using like OpenGL and stuff directly. I think that the modern, a modern Go 3D engine, which I think Go 3D or G3N. I think G3N is the modern Go 3D engine, and it's cool, but it does require, modern OpenGL, like DLLs and things like that, or not DLLs, but it does require modern OpenGL. I think like modern, OpenGL or Vulkan API usage. So like they support, I think, Windows, Mac, and Linux, and they're working on web, whereas Ebitin supports a lot more because it's just it uses, I think, GLFW on the back end, which supports those platforms natively. Not natively, but it supports, because you can't support a platform natively. Like, I mean, I guess as native as you can get it. Anyway, the point I'm getting at is this runs more not smoothly, but it runs more. It's easier to kind of get into, and should be easier to port, because there's nothing to port. It's just using Ebitin. That's why I wanted to do it. I didn't want to have to like work with something that does not or may not ever support certain platforms, or may not really get off the ground in terms of usability. I wanted something that's relatively easy to use and that I could be relatively sure would work for my use cases, which I think this does. I think this works okay for my use cases. We'll call this a net win. Apex Entertainment says, so what inspired you to make a software renderer rather than just using OpenGL? Learning experience, partially learning experience, but because I wanted to do 3D in Ebitin, I wanted to make a game with Ebitin and do some 3D in it. I didn't really envision making like a full 3D game. I thought that I wasn't sure that I would be able to do that, but I mean, now it's looking like I'll just be able to make a 3D game. Like it's kind of crazy. But yeah, like this is not really this is kind of cool. It works. That's just kind of it. It's just like I don't know, man. It works. It works pretty well. It's not bad. And also it kind of opens up room for experimentation in terms of, you know, doing things that maybe modern APIs don't support. Lucretia says, "Whoa, you got animations in there?" Yeah, I got animations in there in a couple weeks ago. And fixed an issue with blending animations too. Is there IK? No, there's no IK. I think I'm gonna keep it pretty simple to the level of like a PlayStation 1 or N64, that kind of stuff. The animations are just nodes though, so if you wanted to manually do it, you could manually do it. You can just bend. You should be able to just like bend a node as necessary. So like you would move, for example, one arm. Really, just rotate one arm to point to another object or whatever, and that's kind of like IK. Like it wouldn't be, I think, that hard to like implement. It would just have to kind of work on top of the existing animation system. Yeah, so this is interesting. Is this your own animation system, or did you import some sort of Blender export? Everything exports from Blender as DAE or GLTF/GLB. DAE works, but it doesn't support animations, so that's why I also made GLTF an importer for GLTF files, because that supports different animations. It supports embedding images like textures in the file as well. But yeah, it's kind of cool. You should call this engine Jankdot. Yeah, it's definitely kind of a Frankenstein kind of thing. It's kind of weird. TJK says instead of tetrahedron, it should be Wonkahedron. Oh, I wonder if Willy Wonka, like wonky. I hadn't even really put that together. I guess I'm kind of stupid. I never thought about Willy Wonka and thought about it like, oh, he's wonky. He's wonky. That's why they call him Willy Wonka, because he's wonky. I always thought, I mean, I knew it's like, you know, wonky. Like, you know, you think Wonka, and it's like, okay, that's kind of like a crazy name, but you don't think it's because he's wonky. That's where it comes. That's why they call him that. Anyway. All right, so now we will try. Now I'm starting to believe. So the general idea here is basically we want to check to see if the player collides with anything while he's moving. Easiest way to do that is to just do it. So we will do it like thus. You know what? We do have access to the scene. So what we're gonna do, we're gonna make a little thing, a little thing. We're gonna say bounding objects is, you know what? We can't do it that way. We can't do it that way. Bounding object. All right, there we go. So we'll have a list that basically contains all of our bounding objects in the scene, and then the objects can use that list to determine what something might be collected. That's the general idea. We're gonna keep this as simple as possible because I don't want to have to make a complicated thing. So we're just gonna say scene.boundingObjects is this. In range scene dot children person. Scene.bounding objects pinned bounds. All right, so now this lets us basically know what bounds are in the object, or what bounds are in the scene. So we should be able to say, for example, or we could just say print out player scene bounding objects. It should give us a list of 2, or a slice of 2 bounding objects. That is exactly what we got. This one and that one. Cool. So now we're just gonna say for O in range player.scene.bounding objects. If O is not equal to, and we'll keep a reference to the bounding capsule. expand? May I? Can you? May I? Can you? Have you ever had a dream? Okay. Have you ever had a dream? It just wouldn't expand. All right. So player.bounding capsule. Oh, capsule anymore? We're good. And then we'll go over here. Capsule. All right. So now we'll just do a quick check to see if we collide with it. So we say intersection equals player.capsule.intersecting or intersection. If intersection equal nil, then player.movement vector 0 equals 0. So for now, we're just gonna basically stop the player if he touches a wall or something. This won't work, but this will be a good proof of concept. A new code editor in Golang. I don't feel like I need to do that. I could do that, but I don't feel like I need to. We can't move because the player is understandably touching the ground. So that means it's working. Cool. Now let's make it so that the player moves out. In TV, let's try that. So that should basically make it so that he'll move out of the way. Wait, hold up. Wait, hold on. Oh, I see what was going on. All right. Yo, it's not working. Oh, wait. Can we scale it up by like a little bit? Oh, my bad. Okay, I see what's going on. Right. How do we want to do this? Hold on. Let's do this. We will... Let's try something here. We'll try it like this. Break. I have to do this. Fine. Let's see. I love the block of debug info being printed at 30 FPS in console. Yeah, it's the best part of my day is spamming console. All right. So he's getting stuck. He's stopping, but he's getting stuck. Why is he getting stuck? Is he moving? I don't know why I did this. We could just do this. There we go. Okay, so the movement vector. I think what we need to do also... Let's try this, because I want to do it this way. Try that. This might be a better approach. Apex says, I like Go, but I don't think I'd ever be able to move away from AngelScript. He gets stuck again. This is interesting, because I tested this before, and it worked well some other way. So let's see what's going on. Clearly, it's still intersecting. That's obviously the problem. So, oh, that's what I need to do. I think we move it, see if it's intersecting, and if so, move it back. There's a couple ways to do this. One is to move it, and then if it's intersecting, move it back. The other way is to move See if it's intersecting. Yeah, that's... We'll try this. We'll try this. We'll move it on the... I guess we don't have to do it. So we'll move it, and then if there's an intersection, we will move it back by delta. Let's try that, yeah. There we go. Not perfect, but it's not too bad. He's a little he's This is so stupid. Oh, hey, he's working. Yo, it's working. Look at this dude. Look at this dude. He can't go through walls anymore, dude. Can't go through walls anymore. This is taking 0.2 milliseconds, which isn't bad. That's not bad. You have 16 for 60 FPS. All right. Well, this is a good start. This is a good start. We're getting there. All right. So what we'll do, and he also can kind of like slide and stuff. This isn't bad. This isn't bad at all. All right. Let's make him a little bit thinner. He's a little chunky. Let's go back to this human here, and we'll just like make him a little bit. Yeah, a little bit. Just kind of go in a little bit around him. Yeah, that should be fine. Export this. Yeah. Jittering in corners is a staple for 3D classics. It is though. All right, this is better. This is better. He's still gonna jitter. That didn't change. Don't get it twisted. He's still gonna jitter, but that's fine. He's a jitterbug. All right. Let's go ahead and turn off that. You know what? Let's make it so that the scene, the debug options can be kind of triggered, so that we can kind of like switch them on and off. Text. Bounds. Centers. I'm just gonna actually just put those both together. So debug. And then also it would be cool if we could full screen it with F4. All right. Someone should make game mechanics around jittering. Speed runs. I'm gonna call speed runs and say that those are basically the same thing. Oh wait, I think it's... There we go. You know what I'm waiting for, Solar? We need to bring our boy Pop back. Pop 64 is dead. No, I do. He does need to come back. He does need to come back. Pop 64 would be good. All right. Cool. Now we just need... Oh, wait. That's where I was going to test. Can we full screen it? And then also we need to be able to switch on the debug. Switch on and off the debug. There we go. Cool. Beautiful. Nice and smooth. And then, so I guess debugging should actually be outside of the scene, but I guess it's fine. Scene.debug text. Pop in Tetra3D would be cool to see. It would be cool to see. I have no idea if I could... It's kind of interesting because before I I like worked on this, I had no idea how you would do like 3D collision. I had no idea. I was just like, how did you even do it? How would you even do 3D collision in a, you know, by code? And it's like, oh, you just do it. it's not like it's not impossible. It's definitely kind of hard, but it's like, you know, it's a solvable problem. Not necessarily perfectly, but it's not bad. How does depth texture do in terms of long distances? Not especially lots of triangles. Depth texture rendering, actually, I guess it'll be probably good to depth out 3 depth. Let me see that. Should be able to use the same draw options. There we go. So the way that the depth texture works is, as you can see, it basically uses vertex colors. So, like, basically, it uses vertex colors to draw the triangles for each triangle of every mesh. But it uses vertex colors, you know, it sets the vertex colors of the triangle to be the distance from the camera the vertex is. So basically, if you have a really long distance with very few triangles, it will interpolate over the distance, but it's not going to be accurate. So basically, poorly, in answer to your question. The answer to your question is it doesn't do it particularly well. So like this is fine, but like if you had a really long like wall, the object might not like intersect correctly. Like it might look to be kind of like behind or in front because like the triangle is, let's say, like, so it's like dark gray here, and then it's, you know, white here. So here is the midpoint of the triangle, and so here's the midpoint of the depth, but you're losing fidelity essentially. It's an interesting problem. You can see it. Let me see. I think I can show you what I'm talking about. Lucretia says that's awesome. Thank you. TJK says that looks like Silent Hill. It kind of does look like retro stuff. So I don't think I can actually show you it. But basically, this is a little demo of like the Tetra3D logo. But essentially, the problem that you're describing is visible if this were backface, if you could see the back, because let me see if I can turn it on. Oh, this is the lighting. That scene, that root, that get screen. No, logo. This is what I'm talking about. All right, I guess the easiest thing would just be to turn off backface scrolling, just for this example. So we don't need this. All right, so basically, when you look at the back side, you can see how the letters start to phase through the back of the triangle, because here we go, because the depth of the triangle like it's not even. So like the closer it's kind of hard to explain, but basically the depth of the triangle is interpolated over the triangle, the blue triangle in this example. And that is, despite the fact that the triangle is closer, the letters appear closer because they're closer like their triangles are closer. Like the corners of the T are closer than any part of the blue part of the triangle. Until they're not like that. So it's kind of an interesting rendering issue. Kind of an interesting bug. You can solve it by simply adding more vertices, or just turning on backface scrolling, which is fine. But it's a very interesting problem. Yeah, very interesting. Let's undo this. There we go. Export it. It does answer. Thanks. Cool. That matches the Frankenstein dude pretty well. Oh, TDA. Hold on. Yeah. So now with backface calling on, obviously you can't see the other side of the triangle, and so it's not really an issue. Yeah. So it's interesting. You gotta kind of learn to work around the issues that come in. You want to have not too many triangles, but enough to basically give some depth, to give some information to the depth texture. And for the guy who said, or the guy for TJK, there we go. So I've seen I've shown this video, this example before, but yeah, like the heavy fog definitely gives a really heavy, really heavy kind of Silent Hill, early PS1 survival horror kind of thing. Like it definitely feels. This is peak PS1. This is just like, oh my gosh. But I mean, this is also something that you kind of like lose in modern, like that's why like Judo is talking about. It looks dope. Firstly, thank you very much. Do you know how well off software rendering would be for games like Dusk and Gloomwood? Yeah, there's definitely a renaissance of like PlayStation 1 styled games, which is crazy because we're living in an age of PS5 and people are still like software rendering. People are still like PlayStation 1, like what, PS5? No, I went PS1. But it does give a different feel. Like it does look different, and this is kind of even this kind of like aggressive fog is something you don't really see in games nowadays. Like you'll have like darkness, but nothing like where the colors are blended quite like this, where it's just kind of like it looks like a PlayStation 1 game, and it looks creepy. I like that. I like the aggressive fog. I like the way the colors are blended. Like there's differences between these two blend modes, even with black. It definitely looks and feels different. Yeah, and let's see. Oh wait, no. Let's do. Excuse me. Where, okay, I can't do, that's weird. I thought I could. It's not work. You went scene. RGB. Do I use this anywhere? Oh, I see, because it's float 32. Okay. Because shapes has errors. Bro, I don't. Okay. Let's do it like this. Yeah, okay, so it does recognize. Oh, okay, so there we go. Color C.R. Unit 16. So I'm just doing this because this is kind of missing. Oh, I guess RGBA is fine. There we go. Max uint 8. You know what? There's no reason to not do RGBA 16. You might as well get a little bit more bang for your buck there. All right, then we can go here and we can just say scene.fog color to there we go. And we can go back over here. This should be instead float 64s. Float 64. We got our RGBA. Okay, cool. Excellent. Right. So I did this because there we go. It's almost there. Oh, actually, I think it's, yeah, it would look better if it wasn't additive. Hold on. There we go. Now we're Silent Hill. Excellent. Yeah, this is why it's so cool, dude. This is why it's just cool to mess around with stuff like this. Yeah. So that's really the cool part of making games, is just having control. Judo says this looks insane. Thank you. Depth of field, yeah. Games feel too polished. I think that games can kind of feel a little polished, like kind of not overly polished, but they can feel kind of heavy. But this was red before. I do think that games can kind of feel like a little heavy, a little much. And it's interesting because there was a thread or a guy on Twitter that I don't even think I followed him, but I appreciated his sentiment, which is basically the guys who he was talking about, a post that he read referring to the guys who made Project Zomboid, which has been in development for like 13 years or something like that, and it's like really doing well now. Like it's you know, got a lot of players, like 64,000 players or something like that, like a lot of players. And like they said in the little like interview that he posted, screenshot of the interview he posted, they basically said something like, by making the game look worse initially, they were able to focus on systems that were fun, and then they made it look a little better. So now they have kind of the best of both worlds. And I do think that and the guy who reposted this opinion basically agreed and said that a lot of games look great now, but there's not a lot of interactivity, there's not a lot of depth in terms of systems. Fundamental systems. I kind of agree. Like, there's not a lot of like interactivity in a lot of games. There's not a lot of possibilities. It's usually just kind of like, oh, you can kind of shoot stuff. Oh, you can do takedowns, or you can do some basic close quarter combat. Oh, you can talk to people. And that's kind of it. like in most games, it's like, okay, if we want to introduce variety, we will allow you to maybe do some mini games. But there's not a lot of like, oh, if you want to make a bridge across this thing, then why don't you chop down this tree or something like that, like Breath of the Wild did. And Breath of the Wild is still like kind of unparalleled in terms of like giving you the ability to do things to affect your environment or just like give you options. I think that having a worse looking game can kind of push you to emphasize other parts of the game more and just be like, I'm not going to really focus too much on the visuals. I'm going to focus on the gameplay. Liam says, can I ask what your experience was like dealing with loading 3D assets? Did you manage to make the process of getting the data from GLTF straightforward? DAE was relatively easy to load. GLTF was horrible. Well, it was bad because I was trying to do it on my own. I ended up using this library that someone wrote in Go to read GLTF files and like decode them and stuff. Because otherwise it's not horrible, but it's a lot of like reading data from buffers and then like rearranging them into like, you know, coherent data that you actually need to use, which is a little awkward. It's a little tough to wrap your mind around, but overall it wasn't too bad. It took time to get here, but you know, it took maybe a few days to like, you know, hammer it away, but it was solid. It wasn't too bad. I had a couple of things I had trouble with, but it wasn't too bad. And I forgot to answer you, Lucretius, earlier, but the animation system is, the data is exported from Blender into GLTF, but the animation system itself is actually Tetra3D. Like, you know, transforming the nodes and everything and stuff like that. That's, you know, that's part of the process. Ayo, Noah, how's it going? TJK says, to further those sentiments, think of what most engines consider as selling points of the features, graphics, pipeline related stuff. Comparatively, you don't have a lot of tools for game design. You are correct, and that's kind of the thing I posted about on Twitter a while ago, like a few days ago, where was essentially, you know, you see a lot of games that a lot of people think of next gen and they think of the next console or something like that, like, you know, oh, the PS6, you know, once we get there in a few years, that'll be next gen, or the PS5 and the Xbox Series X was next gen, S and X. And, you know, I would say the Switch was next gen because of its ability to, like, you know, like that was actually kind of a game changer to like have a game that you can slot in and kind of, it's the same game running on your computer or on your TV as it is in your, you know, on handheld. That was kind of like a cool idea. It really is just like the Vita did the same thing, but instead of attaching a cable, you just slot it in. It's kind of cool. And there's no like Vita PS3. It's just the Nintendo Switch. It's just one console. So that is a little bit of a game changer. That's kind of next gen. But a lot of people think of next gen stuff for like, as like a lot of people think of next gen stuff as like you know, like, oh, you know, PlayStation 6, you know, visuals, you know, Unreal Engine 5 visuals, like, you know, more polygons, more shaders, more, if we can push more power out of a graphics card, that's next gen. And most people kind of forego like the actual game design aspect because a lot of games haven't really changed in the past 20 years. Like, I mean, you know, you think of like, what's the difference between 2021 or 2022 and 2003, and it's like games don't look like brown garbage. That's about it. Like the core gameplay systems are roughly the same. Like you can make a game, like if you take a PlayStation 1 game made in 1997, you could release it as an indie game in 2022 and a lot of people wouldn't be able to tell the difference. Like they just straight up wouldn't know, like because the game design language hasn't really improved. We still use menus, we still use both analog sticks, we still use all the buttons on the controller, and I'm not saying that that's a bad thing, but it's just like I would hazard to say that we aren't very far along in games. I feel like next gen is just mainly like visual and audio stuff. It's not a lot of like the game systems have been improved. It feels markedly, dramatically better to play a game made in 2021 compared to a game made in 2003. It's like a good game made in 2003 or 1997 or 1990 is a good game. I don't think that you could really tell the difference. Let's see. I think that we need more tools for game design. I think in general, I think developers need more improvements in terms of approaching problems like game design and stuff like that. Yeah, I think that there's room for more. There's room for more. All right, so this is working well. Lottie says, "What do you do for a day job?" Currently, I work on MasterPlan. That's what I do for my day job. All right, so the plan here next is to do input stuff. There's definitely quality of life improvements and less clunkiness, so it makes a good opportunity to revisit expanding game design. I do think that games are less clunky, or some games can be less clunky now than before, but I think if you think of clunkiness as like responsiveness, you might be disappointed. Like, I think that there's games that are kind of clunky, but that's part of the design. Like Shadow of the Colossus, it was kind of clunky, it was kind of heavy. Eco was kind of clunky, it was kind of heavy, but I wouldn't really change either of those games because I think what they did exceptionally well. I don't think if you had the opportunity to redesign Eco or Shadow of the Colossus, I probably wouldn't do anything in terms of like making the game different. Maybe the combat in Eco, maybe, but I think that's kind of the point, right? Because Yorda is supposed to be like relatively weak, and you're a kid, you're weak, so you're not really supposed to like, it's not supposed to be like you dispatch enemies with ease. You're supposed to kind of like struggle with it, and you're supposed to maybe try to like get her to a good safe position and stuff like that. If you could just like easily hack through enemies, then you wouldn't have to think that hard. I think that's something a lot of games kind of struggle with, or a lot of game developers or players struggle with, is intentional clunkiness. I don't think people understand intentional clunkiness or how systems are made to interact so much as they think like, oh, good combat is fast and fluid. And it's like, that is a kind of good combat, but I don't think that is good combat. I think clunky combat exists. I think that, as an example, or puzzles that are not necessarily the most easy to understand. I think, in universe, if it's not supposed to be easy to understand, I think that should be kind of the point, right? Like if you have a game where maybe it's kind of like a game about being in someone's mind, and the game, the characters don't communicate, using hard, English or hard language, and it's kind of more like concepts and stuff like that. Maybe puzzles should be similarly difficult to grasp or abstract compared to, a puzzle where it's like, here's the key, find the lock, where it's just kind of like told to you what to do. So I feel like intentional clunkiness is something that doesn't get explored that much, and I think it's easy to forget about it. Unintentional clunkiness is a good way to differentiate it, yes, but I do think that a lot of games don't have unintentional, like, I don't think that early games necessarily were unintentionally clunky. I think that a lot of early games were, but I don't think that there were that many, maybe. I don't know. I have to go back and maybe play some like old PS1 games or something, because it doesn't feel like Mario 64, as an example, is like miles clunkier than Mario Odyssey. I do think there are clunky areas. The camera it needs to be improved. It's definitely not like, stellar. I think the camera is bad in some cases. I think, Mario not sliding on the wall, that was a great improvement since Mario Sunshine. I think being able to slide on the wall rather than bouncing off if you miss the wall jump, like, that is clunky. But like, I don't think Mario controls that much worse, especially when you look at people speedrun like Mario 64 or other good games from 20 years ago. It's like they can do insane things because they just practice with it. So it's interesting. I have to think about it some more. Friction in game design isn't appreciated too much. spiky versus soft game design. Yeah, I feel like a lot of games nowadays, or I can't say a lot of games, but I do think that games are maybe made by, indie developers or a variety of developers look at systems as kind of individual things that you have to get right, instead of looking at them as to how they coalesce and combine. And I think that's why you might have a game that looks great and has maybe the tenets of a good game, like, oh, it's got crafting, it's got combat, it's got guns, it's got like moral choices, it's got a really outstanding plot, it's got best in class combat designers and like encounter designers, and it's like that's all great, but those mechanics don't coalesce in any meaningful way. Like, does the crafting help or inform the player to make better decisions or change the way he plays the game? Does the moral decisions, do they play into the plot? If these things don't combine, you might as well not have them. And that's why you'll have games come out that are like really hyped and look really cool, and then people buy them and just forget about them, because the systems don't really coalesce. They don't mean anything. They're not, they don't mean anything, but they don't combine and mean something more than they do individually. I guess that's the idea. Like, you think about as an example, Super Mario World. You can run and you can jump. Let's just take those fundamental mechanics. You can jump to get on stuff. You can run to move faster. Running makes you jump further, and holding run also makes your aerial movement more controlled. Like, not more controlled, but you move faster in the air, which means that you can jump and then use the run button to save yourself if you're going to like jump off a cliff. You can like jump and then like run back in the air, like hold run and hold left to like move a little bit faster and get back to the ground. Those systems combine in a meaningful way. I feel like a lot of games just kind of like don't combine. The systems don't combine in a meaningful way. They don't coalesce. They don't inform each other. Klonoa was unintentionally clunky. Near impossible. Smoothing it out was more enjoyable. There's definitely friction that needs to be smoothed out in game design. But I do think that there some communication needs to be had about how much friction or is too much, or if friction is too much when you're talking about making a game, especially considering that I'm thinking, hold on. Oh, especially considering that the more there's a certain amount of friction that needs to be in a game or a puzzle or something for people to wrap their minds around. Like, if you have a good puzzle, the solution isn't immediately understood, and like you could have a puzzle where you solve it within a second or a minute of looking at the puzzle, first being introduced to it, and then you have puzzles where it takes an hour or 2 or 5 or 10, and that's a bad puzzle. Let's say people are like, this was too hard, or it was not obvious or whatever. But there's a certain amount of there's a certain range where it's like after 30 seconds of struggling, we're in the good range, and after 3 minutes of struggling, we're out of the good. There's a certain range of friction with a puzzle or with mechanics that players basically interact with, and then after they get through that period, it starts to get good, and that's when they start to enjoy it. An example of this is Monster Hunter, where after a certain amount of time of being like the controls are clunky, and I'm getting hit because I'm dodging and there's no iframes, and it's like there's iframes. You just suck. That's just what it is. Like, there's iframes. You just suck. And that's okay. It's okay to not be good at a game. There's nothing wrong with that. But like, you struggle with Monster Hunter. You're like, why are my weapons so slow? Why does it hurt so? Why is it so tough? And then you start to get it. So that there's a, and that's why it's so rewarding, is that it's not immediately rewarding. You have to invest. So that investment period, that investment effort is what I think a lot of games miss. You can't just have a game be good and be like, it's a good game because the systems are good. It's like, well, you have to invest in the system. You have to invest in a puzzle. You have to invest in communication with the characters in the game. You have to invest with the plot. If you have to invest with them, that means that the payoff is much better, because you have to work your mind through a funnel. You have to work your mind through a communication with the developer. if the plot doesn't challenge you mentally or emotionally, if the mechanics are relatively simple and it's always easy, not because the game is asking a lot of you, it's just the game is throwing a lot at you and you always have the mechanics to deal with it, it's just a matter of time. That's not really that interesting, right? Like, you know, if the game makes it so that the combat, for example, is very simple, it's very easy, you can, you know, always do whatever you want, and it's just a matter of, you know, like if the game is such a game where the combat's simple, it's easy, you can always do whatever you want, then the challenge of the game comes from throwing a lot of stuff at you. Whereas if the game is timing, movement, spacing, all that stuff, the game doesn't have to be that complex. You know, I get an example is, Monster Hunter again. Like, you know, you're fighting one monster at a time. It's one guy. He's doing one thing. Usually, you're just fighting one monster. And it's like, you know, you're constantly blocking and dodging because it's not trivial. If you make it so that it's always easy to do what you want, then the game becomes trivial. And now the monster is like, okay, well, now I gotta have guns. Like, now the monster has to have a sword because it's like, yo, this, you know, the hunter is just like rolling across everything. He's, you know, okay, now I gotta, you know, throw out acid. Now I gotta, you know, do this. Now I gotta do that. Now the stakes have to ramp up to make it more difficult, to make it more of a challenge. So it's interesting to hit that line, I think. A puzzle that takes hours to solve might be amazing in context if it's in the context of a larger game. Yeah, and there are puzzles that take hours to solve in real life too. I know that there's quite a few people who do puzzles like that, where it's like, you know, this is an impossible puzzle, and they might struggle with it for, you know, 2 or 3 hours, and they're like, this is so hard, and then they finally get it. But that's an individual puzzle, and that's kind of like it's supposed to be a hard puzzle, as opposed to a puzzle in a game where it's supposed to be informed by the players' like decisions, and it's supposed to be informed by the plot and by the world design. And then it's like, oh, use the banana on the Switch. It's like, why would I use a banana on a Switch? Like, what? That isn't a good. Like, if there's no reason to do it, then where's the puzzle? Anyway, all right. So this is working. We solved this like an hour ago, literally. Anyway, I've been ranting for an hour. Apologies. Each player's mileage can vary. That's true. There's already a game called named Shut In. Really? I didn't. Well, I guess it's not that surprising. It's not that good of a name. Not that unique of a game. And hello, E-Boat, right? How are you feeling? Thank you. I'll have to rename it something else. I originally named it Hikiko Mori. That's what a Shut In is in Japan, but that's stupid because this isn't a Japanese game, so there was no reason for me to name it that. So instead, we'll name it something else. Name this something else. But yeah, that's that's what it is. Majora's Mask was a bad remake video. It's basically this. The changes took away the friction that really shaped Majora's Mask into having its own indescribable friction feeling. Oh, the 3D version. I never played the remake. Hopefully they didn't take away. I'm not sure. But that would be unfortunate if they took away the things that kind of made it difficult. Certain games appeal to certain personalities. I do think that there's room for Dynasty Warriors, just like there's room for Dark Souls, just like there's room for Batman, just like there's room for Cave Story. Like, you know, each of those games does combat differently. And I think that, you know, and Metroid, and, you know, any game, there's room for different games. I'm not trying to say that games have to have friction, but I do think that games should have friction to engage with the player in a meaningful way. It's rare to have a game that doesn't have friction in some way still be like a 10 out of 10. Super Auto Pets, super popular game. There's tons of friction in the game. Not in terms of the mechanics of like buying and selling, although you could argue that there is numerical friction, mathematical friction in exactly how many pets you can buy or sell. They always start you with 10 unless you have a pet that changes that. So you always have enough to buy 3 pets and roll once. If you roll once and don't get a pet, then you will have to spend essentially a pet to find one, hopefully on the next consecutive rolls that you want. So there's numerical mathematical friction in the game. It's not like you can just roll as much as you want, because they could have made rolls free and then just say you can only buy 3 pets. that would be a more frictionless experience in that you can always shop, you can always look for another pet. You can always look for the pets you want, or if roles were separate from pet purchases, so you can buy 3 pets or roll 3 times, and roll 3 times. Less friction, but the game would suffer because you don't have to choose as much. It's very tightly balanced. The game is very tightly balanced. There's friction in game design in a lot of different ways, in a lot of different games, and I think it is a disservice to you as a developer, or to us as a developer, to discount friction, or to think friction and kind of the knots of the game, discount that as being inherently bad. I think that it's good to have something there. There's always going to be something there, and it's good, I think, to have something there sometimes. I don't think it's always bad. I think that there's room for things to happen. Now that I've ranted for another 40 minutes, we will keep going. It's 12. Okay. So what we're going to do here, I could add a light. Let's work on the systems. What I was going to do is since I forgot, now I've recalled input. I'm going to do input. So let me grab this input module from this other game I started and was kind of working on. And this also is an example of how I'm going to do scripting when I get there. I figured out a way to do it in Golang that worked really well, and is exactly basically what I wanted, which is essentially the ability to run a Go routine like a coroutine, where we can pause execution and then pick it up later. And we do this by using a yield channel and a continue channel, and then running things on another Go routine. So we run a and I guess I'll just copy this at some point when I actually want to do it. But we run the update function for an event. The update function for the event is this, as you can see, we're defining it here, where we, for example, lock the game. We maybe set the dialogue, and then we can wait until something gets done. So we can say like, oh, wait until we display this text, and then wait some time, and then yield, and then you can do some stuff. So basically, the yield system sends data on the yield channel, and then it waits for data to come back from the continue channel. So only one Go routine, either the main Go routine, the engine routine, or the event Go routine is running at a single time. Only one of those. Very interesting. It's a very interesting approach to things. Works pretty well. So we'll look at that some other time. This is what I'm looking at. Where we want this input. We're just gonna copy this entire thing. Might I may not. All right, well, whatever. That's fine. So GJK says, trying to recall, but you mentioned that on an average machine, the expected triangle count could be between 5,000 and 6,000 triangles. I would argue that would be a solid guess. Might look for an older machine like 2011. Depends on the specs. Like I would have to look at the machine. Mostly it would depend on the CPU. If you had any kind of a dedicated GPU, that would probably be enough, because it has to generate it doesn't have to, but it can generate a depth texture for depth testing, and so that's kind of important. But from the stress tests, I'm able to get 40 FPS at 30,000. Yeah, 40 FPS at 32,000 triangles. So yeah, if there was like 5,000 triangles, because this computer is it's a 3.2 gigahertz CPU, So I could probably get, let's say, just keep this, you know, the way it is. If I were to have 1/4 of the, or 3/4 of the number of triangles, I'd be hitting 60 FPS probably. So that would be like 24,000 triangles. So then if I was, and this is just a single mesh. This isn't individual, or no, three objects. So three, like each layer of cubes is one object. So there's 3 objects here. So if we divide that by, and this is just guesses, this is back of the napkin math. If we have a 32,000 triangle scene here, we divide that by, or multiply that by 75%, basically, you would end up with, to get 60 FPS, you would end up with, I guess we could just do the math. Let's actually just, let's test it out. We will go over here. We will, we will just do 2 layers and see if we get 60 FPS, which we definitely should. Yeah, so we're getting 60 FPS with 2 layers. So 21,000 triangles. And this is a 3.2 gigahertz CPU. So yeah, if you had a computer that was like 2.2 gigahertz, you could do a third, roughly like 66% of this. So that would be another like down another 6,000, 6, 12, 18, 7, 14, 21. Yeah, 7,000 triangles roughly. And I know this doesn't like track. I know that this isn't correct exactly, but I would guess that you could probably do 14,000 at 60 FPS, maybe 10,000. Yeah, like so 5 or 6,000 for like a 2011 computer that had like a 2.4 gigahertz CPU. You'd probably be able to get 60 FPS, probably. These are guesses, but I'm just like, it's hard to guess like that because you have different CPU, styles. Other people know more about it than I do, and I always, not always, but I've heard that it's like you can't really do that kind of math that way. Your machine's 2.8 gigahertz, so maybe 7 to 10,000. I would probably say so. You would, if you had more cores, it would be good, because even though this is not multi-threaded, Go still uses other threads, I believe, for other Go routines like the garbage collection and stuff like that. So Annocator says, oh snap, you're writing a software renderer? Yeah. Yeah. You can go back to earlier in this video or go to a different, like 2 videos ago or something like that, where I mentioned I'm Tetra3D, I'm working on it. But yeah, it's a 3D software renderer. So yeah, you could probably hit, I would say on 2.8 gigahertz, yeah, probably 7,000 would be, 7 to 10 would be somewhere around there. You can give it a shot and see. Yeah, your GPU does come into play because it has to, we're still using the GPU to render the triangles. So if you have any kind of a dedicated GPU, that would be good. If you did not, then that's going to take away from your CPU. So yeah. So you do need some kind of a GPU, but I don't think you need a very powerful one. This example that's getting 40 FPS. Okay, so this example is getting 40 FPS. If we go to NVIDIA SMI, it's using 14 megabytes of GPU memory, and it's using like 20% of my GPU, 20 or so. We close it, it goes down to 17, 18. So yeah, it's using like 5 or 6% of my GPU, which is a powerful GPU, but it's not at all like that big of a deal. It's a RTX 2060, so kind of a heavy duty GPU, but like if you had, something that was 1/10 of the power, it would still be able to do this probably. But that's the upside of Tetra also, is just like having something that's pretty lightweight on memory and stuff. That's cool. This example, this stress test is using 86 megabytes of memory, which is pretty cool. It's pretty tiny. 86 megabytes of memory and 16 megabytes of GPU memory. Like that's kind of small, dude. That's pretty cool. Indicator says I've been writing my own engine as well, but it runs on OpenGL. That's cool. That's very cool. All right, so we can't walk through walls and stuff. That's cool. It's a little janky on the corners, but that's all right. Reminds me of PS1 games and a game called Inscription. Yeah, Inscription also is really big right now, or at least seems to be rather large. Yeah. So this is I should mention this every so often, but this is my 3D renderer. Well, it's a game I'm making with my 3D renderer, Tetra3D. If you want to learn more about it or support development, check out my the link in the description for the GitHub repository for Tetra. And you can also support development by checking out MasterPlan, which is a project planning software, and other things that I have on my itch and Steam pages. Actually, it's just that, but check out itch and Steam, links in the description, please. Thank you very much. All right, so input. Let's go ahead and get input working. So the way that input works, we're going to define, because we already have this set up, I believe. Everything is, yeah. So we're going to make a key bindings object. We're going to update it, and then that's it. We can pull it for changes. We're going to put it in the game because that makes sense. There we go. Update, we'll pull it first, I guess. There we go. We will define the keys. We will add. Will be right. We also want a gamepad axis. Left stick horizontal. Left. All right. We also want to be able to use the D-pad. Eboat right says I gotta get back to work on my game. Oh yeah, cool. Sorry, thanks for coming by. I'm sorry I didn't respond to you. Progress is going great. Great to hear. Called Firebound. Creepy, eerie survival-like game where you have to keep a fire burning or lose. Oh, that's interesting. Definitely sounds pretty tense. Very, very cool. Very cool. All right. Thanks for coming by. I gotta hear more about it. If you catch another stream, or if you have an itch page, I would appreciate it. There's no gamepad ID, right? Yeah, no. Okay, so we'll just go with 0. Editing gamepad button. Okay, so the way that Editing works with this. Where's my D-pad? Where's my gamepad? So on the D-pad or on the gamepad, there's buttons, you know, as one would expect, and basically the cluster is the first part, and then the second part is which button. So like this would be standard gamepad button left, right, I believe. For right, yeah, okay. I believe this is correct, and then left for left. Let's kind of do this so we can kind of like look at what we're doing. My project is an adventure platformer and town simulator. It might fall into the action RPG genre, but I'm not trying to stick it in a specific genre. That sounds cool. That sounds cool. I think, yeah, the town simulators and farming simulators, like, you know, Stardew Valley and stuff, they've gotten really popular, and a lot of people like games where you can kind of just chill. Rune Factory comes to mind as one that I liked pretty well. Wait. Top, up, bottom. That's it. Yeah, that's it. Okay. All right, so trying to think for a second. Well, let's just see if this works firstly. Let's see if it works. Tetra3D is single threaded. Yeah, it's single threaded. I believe I can multi-thread it, but I tried it and it didn't give very much of a speed increase. But I'm not sure if I did it correctly. I might have messed it up. So I kind of got to see. Also, let's get some more music in here. This is kind of a classic. But yeah, I still need to multi-thread it as well as optimize it. So we might be able to get some more, like squeeze some more juice out of it, because you know, if you could squeeze more juice out of the process of transforming the vertices, then you're kind of golden. If you mimic OpenGL's vertex and fragment shader passes with threads, it could give some kind of boost. Yeah, that's why I'm kind of thinking. I believe you can only render the triangles or send data to the GPU through epi10, like drawing triangles, on the main thread. But vertex transformation could be on another thread. Lighting might be able to be on another thread. We might be able to like push it to other threads, push the work to other threads. At least I believe so. I'm not sure, but I feel like that could be the case. I don't have a globals, do I? I don't. Actually, no. Oh. All right, so this is what we will try. Let's see if it works. All right. I'm waiting for it to connect. In my engine, I have a game tick and the rendering on the same thread. However, the physics queries are run while it's rendering us in a separate thread. Not sure how it would work with Go's concurrency stuff though. Yeah, I would like to try that. The idea I had was to basically transform the vertices while we're doing on a different thread, while we're doing updates on your game. But you wouldn't know, like everything would be a frame behind in terms of the position of objects. So that's not really, that idea wasn't one I wanted to invest in. It didn't seem like it would quite work. But I'd like to try. Why is VLC? Oh yeah. It's something I'd like to try. Is there, are we not going to connect? There we go. Cool. All right, so let's see if this, yeah, I don't think it actually picks up while running. Yo, let's go. All right, so the D-pad works as you would expect. Up and down on the analog stick is reversed. Up. Cool. Like to keep rendering an update on the same thread, otherwise it's trippy to keep things in sync. All right, well this is working rather well. Okay. Currently you press up. I'm not sure if I like this. You press up and it goes upright. Like this is pressing up. So you're basically moving in like an isometric viewpoint. I'm not sure if I like that. Kind of gives a little bit of a like survival horror-ish. Your actions are aligned to the game world as opposed to the camera. But yeah, I mean, I guess this is fine. Yeah, this is fine. All right, we're good. So this works. That's cool. What if we were to just kind of start like actually, you know, designing the game a little? Oh, I don't have Steam open. 0 out of 10 needs more tank controls. Needs more tank. It needs more tank. Here we go. All right, so yeah, if we could like get something. Also, again, I have no control over who friends me. Please don't get angry at me if somebody's saying something wild in the corner. I have no control over that. I need to learn how to turn it off. Actually, now that I think about it, because you never know. I'm scared. I'm scared. Okay. All right, we're good. Steam makes it kind of difficult. Yeah, I'm not. I gotta look it up. I gotta look it up to see. Why so many? Dude, I don't know. I'm not. I don't know. I have no control. I don't know, dude. I don't know. I don't know, man. Steam roulette. All right, so we're gonna do something like this here. That looks pretty good, I think. There we go. That's beautiful. Maybe actually here. That's not. Like that. Something about pixel art, man. It's just it's just so fun. Yeah, it's what happens when people find your Steam profile. Yeah. Excellent, excellent. It's kind of like some of these little more jank than others. Cool. All right, so this is a good start. This is a good start. Okay, so we're gonna just do this a little slapdash here. Yeah, a little slapdash, something like that. That's the general idea. Okay. I'd like to make a Blender add-on that just allows you to run an arbitrary add-on on save, where you can just be like, oh, I want to do this, and it'll just like do it for you. TJK says, man, this makes me think of urine. Yeah. Yo, look at this. We're walking around in a little space, dude. This is so crazy. This is so crazy. This is like actually kind of insane. It's kind of insane. I'm actually like, yo, this is kind of insane. I'm actually kind of like, I'm surprised. It's just like, oh hey, what if this was this is literally all it takes to make a 3D game, is just like, you kind of, I don't know, you kind of forget, I guess. Like I forgot you know, what it means to make a 3D game, in a sense, both personally, but also like you kind of hype up 3D stuff, and it's like, it's really just math. I don't think I like it being half height. I think I like, yeah, it's a little weird. Mark Hughes says, stoked you're pushing the Go tooling forward instead of cranking out Unity copy pasta. Yo, thanks. Thanks for the $5 too, Mr. Huge. But yeah, that's also a lot of the fun of making. I think that's something you kind of miss when you're making stuff with an engine, is like making tools that other people use. And it's kind of crazy to happen upon people who are like, oh yeah, I use like SolarLune's, you know, importer, and it's like, what, you use something I made? That's crazy. Oh, oops. I'm wondering, why does it look so weird? All right, well, whatever. I want it to be taller anyway. We'll export this. This is fine. Yeah, I really like working in my own code base. It's far from perfect, but it feels so comfy knowing where everything is. Yeah, it's very comfortable. Very, very good. I don't know if I want the camera to rotate. Maybe I do. Liam says, what are you doing to make these maps collidable in Blender? In Blender, I have a property that says collision triangles, and then this gets exported when I export to GLTF. In Tetra, I basically loop through and see if any of the nodes, here we go. I loop through and see if any of the nodes have collision. Basically, when the property is defined, when a custom property is defined in Blender, when you export it into GLTF, it gets turned to an extras thing in the GLTF file. That gets loaded into Tetra as a tag. Tags are basically a way to identify nodes, so it just made sense to like say, you know, this kind of, you know, objects have tags as well, where this gets put in there, and then I can see if an object has collision. Say like, oh, it has triangles, and this will make a triangle mesh. You have triangle mesh collision support? Yeah, mine's still broken. Sorry to hear that. Genuinely sorry to hear that. This is pretty good, dude. this is pretty good. I'm not gonna lie. This is not too shabby. Why don't you use Godot for this project? I don't know, man. I don't know. It's not Godot. I don't know, man. It's fun. It's fun. I don't know. It's fun. It's fun to do things not, you know, to do things in a way that you shouldn't do them. Not really, but it's fun to make games kind of from scratch. I like working with frameworks, I think, more than working with engines. And there's not really a lot of there's no 3D frameworks for Go. There's G3N. You know, there's a couple of 3D, one or two 3D like tools or 3D game development tools, but they are basically Windows, Mac, and Linux only. And I wanted something that, you know, I felt like would kind of grow. And I feel like a software renderer, while not being as fast as it could be or should be, it's fine, I think, for my needs. And it also allows me to design an API I like, and to really like work with it to make stuff rather than just having a theoretical API. I can use it to make games and see if it works. Yeah. Only thing stopping me from making 3D games with OGL is trying to pipeline and import the 3D assets, such as maps, simply, which is why I think this is so cool. Yeah, it's very cool. I would definitely recommend GLTF to export your data from Blender, and then just see if you can find a importer written in your language that can read GLTF files, and then from there it's still kind of tough, but you can definitely look at my resources, look at Tetra3D to see how it loads GLTF files, and then just, you know, basically copy that for your game. I think the issue here, now that I'm looking at this, is that the textures are really blown up. We want them not to be. So here's what we'll do. But yeah, I think a lot of the fun of making games is kind of learning to do things yourself, and also, you know, contributing to a community. I think that's something that I miss as well, is, you know, adding things or making something cool, making something fun. I think it's easy to kind of forget about that step and just get focused on making things. All right, this is pretty good, I think. Although I think it would probably look better if I did something else. I think what that is maybe make it darker. I think it might be too bright. Let's try this for now. Let's just try what we got here. Oh wait. Right. This doesn't actually have to be any. Yeah, that's fine. There we go. The walls. Oh, this is this. Okay. Bump for visibility. Is your texture distortion issue due to screen space UV interpolation rather than world space? It's caused by... Oh, lordy. I don't know if I like that more or not. It's kind of yucky. Maybe it's yucky. I think it's too noisy. I think that's the issue with this texture. It's too noisy. Yeah, that's probably what it is. We're gonna redo this. It's too just like ugly. Ugly as sin. There we go. Okay, let's try basing it like first. We definitely want slats. We can make the slats a little bigger, I guess. That's fine. Sorry. You just realized you have animation support already as well. This engine's already fairly mature. Thank you. Yeah. I'm sorry. I keep forgetting to answer problems because I'm lost in the sauce. Forgive me. Okay, so yes, if you want to write a Blender add-on, definitely do. It's not that hard, and the upside is you can easily distribute it. And you know, I would probably like to write one for Tetra specifically for like spawning a collision shape for a mesh, for example. That would be cool to just be able to select the collision, either no collision, triangle, capsule, or whatever, and then it will automatically make the right size shape, collision shape for the object. That'd be cool. So definitely would recommend writing a Blender add-on, or at least just like making something that imports GLTF exports. Firstly. Secondly, Domo says, is your texture distortion issue due to screen space UV interpolation? No, it's due to the texture mapping is affine as opposed to being perspective corrected. So fundamentally, basically, like when you look at how the PS1 did texture interpolation, it's similar, or UV interpolation. It's not corrected for the perspective, and so you get like really warped UV values the further out of the screen, the further to the corners the triangle goes. Mark says, did you write benchmarks for the multi versus single thread ops, or just feel it out with frame rate? I just felt it out. It didn't feel right, so I abandoned my efforts to multi-thread it temporarily. I have to go back and give it another shot, because it definitely should be possible. I don't quite remember what the issue was. It was just not fast. I was like, okay, well, I must not be doing it correctly, clearly, because I know, it should be possible to multi-thread. The vertex multiplication, lighting should also be able to be multi-threaded. Basically anything except for drawing to a texture. So I'm wondering where the issue comes in. Keep the distortion in for the retro nostalgia value. Yeah, that's what I'm gonna do. I might do like perspective corrected. Like this could actually be longer. I might do perspective corrected texture mapping eventually, but I'm not sure yet. I guess be a little off. Okay, this is, I think, more so. It definitely feels more like wood. We're getting there. Let's see, what color do we want to use here? Kind of get a little fancy with it, I suppose. Just a little. A slightly different color. I guess these are. That's just literally not enough of a difference. Let's see. I guess I could go with a different palette. Yeah, that's so noisy, dude. That's so bad. Give me like a better. Ooh. Yeah, All right, this is what we're gonna work with. I think this is it. So if we can make a single section look good, then we can make any section look good. Let's see if we can make it warp a little. Oh yeah, this is beautiful. The simplicity is, it's delicious. Sorry. it's very good. All right, but we don't want to overdo it. Let's see. Do we want to add any highlights, or I don't think we want highlights. I think instead we want to add more detail. Better. Okay. Okay, go with a little something like that. I think that's a little bit much. Let's go with something. Yeah. It feels very, very Earthbound, very Mother 3. Very Undertale, actually. Add some graffiti. Ooh, that, I like the idea, but unfortunately this is somebody's house. this is indoors, so it definitely should be fine. We could go with something like that, just to kind of, a little something. Too much. Forgive me for always zooming in and out. I apologize. There's a preview just for you. It's a preview as a treat. Is this going to be an RPG? No, it's going to be an adventure game. Kind of like I Know Who I Am. Or, yeah, Iquia. Kind of like Iquia. An adventure game. A little bit of, communication. We might be able to push it a little bit. The coloring here. Better to... Yeah, that purple. Ooh, that purple. Just a little bit of rot. Just a smidge. Just a little bit of rot in there. Nothing that would cause you to call the police, but like just a little like just a little there just to make you rethink your life choices here. We might be able to kind of like add a little. That's too much, but the idea is solid. I think. Yeah. See, this kind of like control over the look of something is something you don't really see that much anymore. All right, let's go with this. Make the graffiti say "get out or die." That's very. Ooh, yeah, dude. Oh, that is beautiful. And look in comparison, dude. The ground was so noisy before. I didn't even realize. All right, but we're on the right track. We just have to do this, and then we're just gonna like take one of these planks and just mess it up. Here and there. Okay, so we're good. I believe we're good. Okay, we can kind of. It's been a while since I've just like drawn something. It's fun, dude. It's fun. I've forgotten. All right, so this is, I think, good enough. Oh, that's pretty good. We don't like this. It's too obvious. Okay, not. There we go. Better. We don't like. Well. Yeah, this is fine. I think this is fine. We can definitely use a different color for this, for the baseboards. Yeah. Simpler. Wooden baseboards. Yeah, it looks like there's no seams on baseboards, so we will do something like this. We're just gonna. Yeah, there's a green. Yeah, give me a nice something paler. Yeah, give me pale. Yeah, a few sparse details. then also give me like a... Am I not saving? All right, let's see how this looks. I don't think I had to export it again, but that's fine. Let's see how this looks. Oh yeah. Oh yeah. Oh, okay. All right. We're PlayStation, you guys. This is solid. Let's see how it would look if I had a smaller viewport. You won't be able to make out the details of the guy's face, but that's fine for now, just to test it out. I think it looks a little too cartoony, actually. That's interesting. It feels a little too cartoony. I'm not a fan of. Also, I don't think that I want like this low of a resolution for the game. Let's see. Okay. That's almost one. Wow, that went fast. Wow, okay. Well, this is pretty good. Overall, this is pretty good. Definitely feels solid. I wonder, let's do something real quick. I want to try something. Let's go to the player. Or go to the scene. Scene graph dot lighting on true. So it should be dark. Is there shoulder sinusoidal height differences for the floor vertices causing the wobbly boards? Okay, that was dark. No, I think it's wobbly because of the perspective, the affine perspective. Yeah, because it's flat here, so there's nothing in the texture. But yeah, I think it's just kind of like it looks like that. Hold on, let me try something real quick. Root add ambient light. Give me an it's fine. Let's give me like low ambient light. Also, it should be dark now, I think. Or dark but visible. Ooh. Oh, look. Oh no. Oh no. Okay. Oh no. No, look at no. Oh no. Okay, so let's add a light on the player. Let's put a light on the player. So we're gonna do the player. I don't know if I will want this, but let's see how it would look if I did. Add children. New point light. Point light. I want it to be white. Give me like a 0.5. That's fine. Not a lot. Not a huge amount of light. Ooh. Oh, that's creepy. Oh, that's creepy. Oh, that's creepy. Ooh. That's creepy. Wow. Okay. Man. All right. It's just like, man, that's. Oh wow. Okay. When I implemented lighting, vertex-based lighting, I was like, I don't really see that. You know, I'll add it, but I don't really see the point. Compared to fog. Like fog is basically just a point light on the camera, right? Like but it really does like change the game. Wow. All right. Give me a 1.0. Give me give me like a little bit of a movement up so it's overhead, maybe. Nightmare Simulator Horror Adventure Game Mode activated. It's like, I think it's in his head. What if the player, and I have this ability to do this here, player dot root dot get mesh? No, and where, hold on. What's my, I think it's armature slash mesh dot, it's a model, mesh material. I could have done this a different way, but enable lighting false. That looks really good. Thank you. All right, now he's just bright. So now he's not affected by the light. That's not bad. Lighting time is less than 1/10 of a millisecond, which is not bad. In practice. Okay, all right. So this is kind of cool, dude. What if we bent let's go to the scene. What if we bent the color of the ambient light? Where's that at? What if it was blue, basically? What if it was like a 0.2 green blue, and then that just kind of made it a little, okay. All right, here we go. Now we're making stuff. Oh no. Oh no. All right. Yo, let's go. Okay, so this is cool, dude. This is cool. All right. Okay. I'm just smiling, man. This is cool. This is cool, dude. All right. Let's make something. Let's make something. So this is the map. I'm just gonna put something directly in the map. There's other ways to do this, but I'm just gonna put something directly in the map. So we're gonna grab this here, set the cursor to active. This will be a bookshelf, I suppose. Oops. It could be a little smaller on the next one. All right, give me. I guess we'll put it here, and we can make it larger too. You don't need the old. I'll keep the old wood just in case. That looks so weird. I'm gonna keep it. I wonder if I can modify it into something else. Yeah, I feel like this is a little too like cartoony, but we'll see, I guess. Wait, how did I? Yeah, I feel like this is a little too cartoony, but I think it's fine for now. Can I get a 90-degree rotation? Thank you. I guess I should really just be doing code. All right, so that's good. I still need a thing for this. Let's actually not put this here in the tile set. I'm gonna put this in its own thing. Yes. You know what? That's fine. I guess we'll leave it here. How big do we want it to be? Maybe like this big overall? Oh, actually, I like that. Yeah, I gotta figure out how to draw like garbage at this resolution. This is overall not too bad. All right, I'm going to just kind of like hand wave the rest of this and be like, that's fine. Now, let's get moving on with the rest of it because I want to see what it will look like. I'm not sure. Also, I don't want this to be maybe this color, maybe the... How am I not saving it? Set it. Okay, so that's what it's gonna look like on the front. Would I like stretch it out like that? Nah, this is correct. Okay, so then the sides are just gonna be, I'm just gonna assume their sides are gonna be just a flat wood texture essentially. Which I will here, I guess. Actually, I guess I can make this color. That. Ooh, that perspective though. Ooh, I'm an artist. I'm an artiste. Look at me. Look at me art. Oh, you can't. Nah, man. You got me drawing. You got me drawing like 45-degree angles, holding control and shift. Oh man, it's over, bro. It's over. I'm an art. I am an art. I'm an art. I don't know about you. I'm an art. Oh, we got perspective. We got actual oh my god. Mark Hughes says, is the inode eye face? Is the inode eye face modeling something in a dependency? I'm not sure what eye face, but I guess you mean like, is inode modeling something in a dependency? Is that interface? No, it's original to Tetra, so that basically cameras, lights, models, bounding objects, they all interface. Oh, iFace interface. I see what you mean. Yeah, it's just basically so that all of those things can be nodes. And that's really yeah, that's really it. It's just so that things can be nodes and all have the same kind of functionality where it's like, oh, you can move them, you can add them to each other as children, etc., etc. That's the real point of it. Okay, we got a little bookshelf there. This will not. Oh, actually, it will work. We'll just need to have it do this. I wish you could copy properties like that. It would be cool if you could. All right, string. Okay, so yeah, there might be. I'll have to probably. I'll end up making an add-on because this is frustrating to do. I mean, it's not frustrating, but it's not fun. But that might be it. I don't know if I have to do anything else. That might be it. Oh, there it is. It doesn't have the. Yeah, it does. Can't walk into it though, or can walk into it. I wonder. It's definitely there. But yeah, it's getting there, dude. It's getting there. Hold on. All right, so why can I walk into the ground with the wall? Let's see. I think this is it. Yeah, there's a bookshelf. All right, bookshelf save. Export. So that's working, but the bookshelf bounding triangles. Hold on, I wonder if no, that's yeah, it seems like it's working correctly. I was wondering if it was like out of position, but it seems like it's where it should be. Yeah, why can you not walk? Why can you walk into the object? Is this on 0, 0? It is. I wonder if that's part. Oh, my bad. I still have to do this. Yeah, that might be part of it. Let's see. Nah. So bounding triangles is at 0, 0, 0. Bounding triangle 0, 0, 0. Bookshelf. Okay, bounding triangles. It might just be not colliding with it for some other reason. Oh, yeah, we can't break. Okay, I see. My bad. I was breaking after colliding with one object. We can't do that. We have to, yeah. That was it. Okay. My bad. This works. Yo, this is kind of sick. I was taking a crack at adding some benchmarks, but mocking big interfaces gets a little gnarly. If the methods that accept an inode don't need all of the methods on the interface, they can be split up and composers need it. That's true. Yeah, I'm not really happy with the way everything is implemented when it comes to nodes. It all works fine, but it's a little finicky and prone to error. Prone to human error mainly because like by composing an object out of a node, like literally embedding a node, anything that the node does, like adding children or unparenting or anything like that, happens on the node rather than the object that composes it, because the object that composes it has its own reference. An example of this, you can see, get out here. Already 115, wow. An example of this is visible really anywhere, but if we go to model, the model embeds a node, and so we create a new node, and that makes a model basically, have a node. And so node and model both implement inode. So a model is an inode, which works okay. But then when you for example add a child, we have to overwrite the node's add child, because we have to basically say I'm the dad. When you add a child to a model, the model can't simply use the node's add children, because the node's add children is going to add children under itself, under the node. And really we want to add it under the model, and so we have to do it this way. So it's not great. We could compose the inode out of sub pieces, but the thing about that is you kind of want a node to be able to do all of this. Like, a node should be able to have a hierarchy of children. It should be able to have a position. There's nothing that a node has to be able to do all of this. There's no situation where you would want a node that can set visibility but not have a position, or have a hierarchy but not have a position. I don't think. There are use cases where I could invent something like that, but they are remote enough where you could just do that with a node that does those things, does everything. So I don't know. It's not perfect, but it definitely works. But it's not perfect. I would like to kind of like have code reuse where we can define a node, have a model basically be a node, or be able to pass as a node, but I don't want to have to like override the functions if necessary. The only thing is G3N did the same kind of concept. It did it slightly differently, but it's basically the same, where it's like you have an interface, I think, where you have an interface that represents what a node can do. You have a node that does it, and you have things that are extensions of a node, but then also have to overwrite anything that uses the hierarchy of the node, because the node that the implementation, the default implementation will point to the default node rather than the overridden version. inode will still satisfy the interfaces it's composed of, but the methods can accept the smaller interface. I guess why? If I may be so bold as to ask, why make additional smaller interfaces if you still have to have inode? If you still have to have the big one, why would you want to make another smaller one? There we go. It's interesting that does this, but this does not. It's kind of interesting. You can test and benchmark the individual methods without having to mock the whole inode interface. I think I see. That's an interesting idea. I feel like the slowdowns are definitely going to be in vertex manipulation. Anything that uses vertex and matrix math, like specifically transforming the vertices, that's going to be the slowest part generally. Lighting is going to be the slowest part because it has to do it for each vertex. It's vertex based. Doing a fragment based shader would be more efficient. I just haven't done it yet. That's something for later. Let me add that to the readme. Yeah, it's not here. Ideally, yeah. So that's the problem, or that's the where it's going to be definitely slowest, is where you go to camera and you go to render here, render. So it goes through, it basically, says, can we any of these objects? No. Okay. Can if it's not if it's close enough, and if it's not, if it's within the camera's frustum, which is also just a sphere, because I'm stupid. And then for each triangle, you transform it. This is where you transform all of the vertices. This is like the heaviest part, or at least one of the heaviest parts. And then if it's skinned, like if it's an armature that's driving a mesh, we do this. Otherwise, we do this. And this is just basically creating the MVP and then transforming the vertices by the MVP. We sort them, because if you don't sort them, they'll just be randomly ordered, which is not good. And then we go ahead and transform those transformed triangles to draw on screen by clipping them to screen, and then backface scrolling, and then setting the positions on screen, setting the colors. So overall, it's not, it's relatively simple, but it's really like this is where it's going to be slowest, is this right here, where we're multiplying the vertices by multiplying the vertex positions by the MVP, which is calculated here. So if this could be faster, that would be it. And there's ways to do it. I think that like making the matrix 4 not use an array of float 64s. There might be a way to make that faster, or similarly for vectors. The matrix 4 is my own creation, but it doesn't. I don't have to use it. I just did it because I didn't see any math libraries that really like did what I needed them to do fast enough. Well, that's not true. I didn't know that the existing math libraries were too slow, I guess. And I'm sorry, Boiler Studios. To answer your question, no, I do not live in Arizona. Nice try. No, I'm kidding. Yeah, I live in California. I live in California, United States of America. I don't know why I said of America, United States. It doesn't matter. But Matrix 4, maybe this could be faster. Maybe we're doing a lot of like copying to heap here. Same thing with vectors. If we could speed that up, that might be it. So there's definitely ways to speed things up. But yeah, if you wanted to like take a look to see how you would speed things up, I guess we can go to the stress test. I would probably, if you wanted to just take a crack at it or take a look, I would just use the debug information. Be like, all right, we're not skinning anything. There's no lighting times. There's no we're just rendering 3 objects. We're rendering 14,000 out of 32,000 triangles. This is how long it's taking. 20 milliseconds, 30 milliseconds, around that area. How do we speed it up? Well, you want to make it so that it renders fewer triangles. Like we have to transform all 32,000 triangles to know which ones we want to draw, right? If we could somehow cut it down so that we didn't have to transform them all, that would be literally 100% faster. If we knew like, oh, these triangles we don't have to transform, or if the transformation process was faster. This is the transformation process. It's of vertices to model transform to viewpoint matrix, projection matrix, MVP matrix. This is the process. So it could definitely be faster. I got it fast. I got it pretty quick. It's not as fast as I think it could go, but I think that it's definitely usable. I mean, we're making a game and it's like 1 millisecond to draw, which is not bad. Yeah, it's sub 1 millisecond. That's not bad at all. Lucretius says Solar. Hello. So yeah, this is going pretty good. I mean, like, this isn't bad at all. This is pretty good. This is definitely up there. I do think that the waviness of the ground is kind of distracting. And it's more obvious, I think, when the resolution is low. It's not as like crazy here, but I feel like it is more obvious when the resolution is low. So I kind of want to fix it just because it looks kind of weird. Although that could be explained hand waved in universe as being like, oh, it's because the ground was so wet, the floorboards warped. Maybe I'll do that. Maybe I'll just say, oh, the ground is so wet, the floorboards warped, and just be like, if you don't like it, too bad. Let's see, what else do we need to do? We need to oh, that's what I was gonna say. I wanted to try this back so I can see the effect a little bit more strongly. Yeah, you can definitely see it. It's definitely more obvious at low resolutions, I feel like. So, I mean, but overall, that's still really good. I still have to got to figure out how I can. Yeah, got to figure out how I can do something about it. I don't know. But it's crazy, dude. This is a software renderer. That's so insane. It almost looks like 3D pixel art. Yeah, it's crazy, dude. I don't even know how to like. Oh, this is so weird, dude. It's wonky, and I love it. It's so wonky. But yeah, I mean, sub 1 millisecond frame time isn't bad. Like that's really good. For a homemade, lighting, for a homemade, what's the word? A homemade software renderer and lighting engine. Like that's not bad. That's really good. I think that's really good. I'm pleased, dude. Like this is, it's completely usable. Like that's the crazy thing. I'm both the guy in the corner at the party and the people at the party. I'm the guy in the corner in the party and also the people at the party. That's perhaps the nicest thing anyone's ever said to me. Oh man, what time? I've been going for like 3 hours and some change. Yeah, I've been going in 3.5 hours. Let me commit this stuff to code. Let me commit this stuff. First commit. Oh wait, yeah, okay. I don't think I have anything set up for a remote. Oh, I do. Okay. I have a remote? I do. Okay. Wait, what? Jank? I don't know, where did that go? What's my jank that I get? Where is this? I don't have a repository named jank. It's weird. I'm not sure where this is going. I mean, clearly it has a remote, but I'm not sure what that remote is pointing to. Can I open the repository? I don't know about this. It's weird. I don't have. Oh, I'm in Tetra. My bad. I didn't even realize. I'm in Tetra. Psh. For some reason, I thought I was here. Okay. No, I am in here. Oh. Oh, I didn't set up a I see. Wow. I'm like, my mind is gone, dude. Completely misunderstood what I did. Okay. All right, let's roll this back. Let's reset. I don't think this will actually do anything. Soft reset. Nope. Let's go one more. Reset. Soft reset. There we go. Okay. I guess this is another way to do it. All right. So anyway, I'll commit this stuff to Tetra. I gotta make, this is what confused me. So you can see the source control for some reason, for connected like things. Like I can see the source control for jank here in shut in my game. Anyway, I'll make a Git thing. I'll upload it and then get cracking on it. I mean, like, keep working on it. But yeah, this is cool, dude. This is kind of insane. And it's so lightweight in terms of like memory. CPU is gonna be heavy, but like it's gonna be heavier than a normal game. I don't even know what this thing's name. Shut in. Okay, so it's still shut in. But 31 megabytes? That's crazy, dude. 31 megabytes of RAM. 15 megabytes of GPU memory. I believe giving unsolicited opinions should cost money. Thank you for context switching away from art to discuss. No, it's fine. It's fine. I appreciate your opinion. I still need to optimize. There's still room to optimize. There's still room to work on it. And I'd love to make more, make stuff to finish this. I think that having options only makes it easier to make cool stuff. Especially, if you have a 2D game and you want 3D elements in there, like the background or the foreground to be 3D. It's cool to have the ability to just be like, let me put a camera, let me, put a plane up and draw this thing. Nice work, says Annocator. Thank you. And Lucretia says you could turn this into a mini console like the Pico 8. That's an interesting idea. There's another guy who's doing this same concept, I think. Is it this guy? Is it this guy? I don't know if I'll be able to find it. Renderer. It is this guy, David Colson. Yeah, here you go. Here you go. Here is the link. Oh, here's his actual project. So apparently, he's doing exactly that. It's a PS1 era fantasy console like Pico 8, but it's 3D, simple 3D. Okay, so he's got like a simple fixed function. Yeah, okay. But he's got GLTF model loading. He's got he doesn't say anything about animation. Only Windows 64-bit. Doesn't say anything about animation. He's got some lighting. He's got some stuff. He's got some stuff. This is cool. This is very cool. But yeah, this dude is making a PS1 styled fantasy console. It's a pretty cool idea. And Bundy says I have to leave soon, but the renderer is looking cool. Thank you. Thank you very much. Lucretius says you're becoming more of a tool builder for game dev than a game dev. Yeah, only Windows 64-bit, unfortunately. But he says it shouldn't be too hard to port, so maybe it's not too hard to build for other platforms. Yeah, it's fun to make stuff make tools. I think tools are a fundamental part of game development, and it's good to have good tools. And I think there's a lot of tools that exist that aren't quite as good as they could be. I think tools shouldn't get in your way. And hopefully, MasterPlan doesn't get in your way. Hopefully, Tetra3D doesn't get in your way. Even if it's not, they aren't like the biggest or the best tools. They don't do the most things. They just do what they do really well. I think that's what I want, is to just do what it does, have something do what it does really well. Yes, multi-platform is really important. I think it's weird to have like a tool or an engine or something be like Windows only. It's like, all right. It's like I'm not trying to be like stuck up because I use Linux. So from my perspective, it's like, well, I can't use it. It's like, okay. Carl says, have you checked performance in WASM? I believe it's poor. I believe it's very poor. It should be okay to render like a couple of objects, but I think it's not nearly fast enough to render even a relatively simple scene. I have to work on. I'm not sure if there's much I can do for that for web, because I can't multi-thread because the web doesn't have threads. They have workers, as far as I know. So if there's no ability to multi-thread, the only thing I can do is optimize, which I can do, but there's only so much I can do. Like, I don't think you'll get much more than a couple of frames per second. Mark says the best tools are often made by people that are solving their own problems. I'm stoked about MasterPlan. No, thank you. And yeah, that's what I would like to make, is stuff to solve problems. MasterPlan being the problem of how to plan a game. And Carl says, yeah, single threaded. Yeah, that's why I believed. So I haven't done too much with web, but I wonder if it's possible to speed it up. But I mean, like, if it's just a slower, if it's just, you know, running Go but 10 or 100 times slower because it's in a web and it's like interpreting calls or whatever, like, it just might be that it's slower. There might not be much I can do about it on that front, unfortunately. I mean, I believe, yeah. I mean, well, there's been work to like run, like be able to compile code to native, right, in web. I'm not sure if Go can interface with that, but I thought that was like one of the big things that they were working on for Go was, or not Go, for web, like JavaScript and stuff, was like the ability to run code like native code, not mscripted, where it compiles C++ to JavaScript, but rather the ability to like run C++ code from within a browser natively on the computer and then like feed the results back to the browser. I guess that's the idea, is that way you could run heavy stuff, you know, natively and not eat a massive performance loss. I think that's the idea. Anyway, I'm not sure if Go can like benefit from that, because if or use that, because if it did, then I would be able to see at least about putting you know, the heavy parts of transforming the vertices and everything onto the user's computer, and then just use the WebAssembly. Well, that's, I'm not thinking of, am I thinking of something else? I don't think it's WebAssembly, is it? Let me see. Okay, maybe this is what I'm thinking of. Maybe this is what I'm thinking of. Okay, so then yeah, maybe I just have to look into WASM more. Maybe there's more I can do to try to target WASM from Tetra3D, from Go. Maybe I can make some optimizations, or maybe change some build settings or something that would basically impact how the code is run. Can't hurt to check it out, I guess. But yeah, it's been fun. I'm tired. Well, not tired, I'm hungry. It's already almost 2. And it's been a lot of fun working on this. I'd like to keep working on this and see if I can make something cool. I think it's cool to make cool stuff, and I think it's great to make stuff that people use and you know, great. Wait, WASM allows multi-threading? Hold up. Wait a minute. So wait, if WASM supports multi-threading, maybe it'll work. Let's see. GoOS is JS, JavaScript. GoArch is WASM. Go build blue.wasm. Does it? WASM supports multi-threading? Trevor Slocum says, thanks for sharing. Looking forward to the next stream. Yeah, definitely. Next stream will probably be next Tuesday. I don't think I'll have one on the weekend, but maybe I'll change that in the coming days. WASM supports it, but not the Go compiler yet. Okay, got it. All right, so then if WASM did support multi-threading, then at the very least I could take advantage of multi-threading the vertex and lighting transformation calls. but even that would be minor. I still would need more. I need more, because I think someone said like even this example. Yeah, they said this example was like running poorly. Like, you know, sub 60 FPS. This is not a visually complicated scene. This is a few thousand triangles, and is like 1 to 2, well, 1 millisecond really, on, you know, native. So for WASM to be slower, it would need to be 16 times slower, 16 to 20 times slower, or anything more than 16 times slower would be sub 60 FPS. So like, I don't know if I can optimize it more, but I have to investigate it more. Does TinyGo support it? If you mean Tetra, I don't know. If you mean WASM, I also don't know. I'm not familiar with TinyGo enough. Is TinyGo faster than normal Go? Or is it just for embedded? Oh, and WebAssembly. Okay. Very compact. Huh. BBC Micro. Does it support does TinyGo support just like normal? Yeah, I'm not sure. Seago, many features of Seago are still unsupported. Okay, so probably no. It probably wouldn't work because I believe Ebiton uses Seago, at least on non-Windows OSs, to run GLFW, I believe. They like interface with GLFW. Okay. All right. Well, this was enjoyable. It was very informative as well. It was a lot of fun. Yeah. So thank you very much for stopping by. If you want to support development, please feel free to check out my links in the description. You know, Proton, Patreon, Itch, and Steam, and all that stuff. And I'll have to catch you guys on the flip side next time. Carl says Ebiton works on TinyGo, which is cool. I'll have to check it out. But yeah, it's been fun. I'll have to see about making some more stuff with Tetra, or improving Tetra, on another stream. This was really, really productive. Thank you very much for stopping by, and I'll catch you guys next time.